Now, I do want to mention that there are lots of problems for you to work on here for practice. On this video, I'm going to do, this is a link off your website, so you can go to the web and get exactly what I'm doing here. I'm going to do this. I'm going to do some extra in-class exercises, but I want you, outside of class, to click this link and give yourself some more practice before you do the homework and quizzes. So please take some time after you watch this video to go in here and click this link on the website and do those. Okay, enough of that. Another problem. From a group of 20 students, 5 will go on a field trip. How many 5 student groups are possible? And this is just a plain vanilla combination problem because order doesn't matter. It's not important what order you choose them in. And whenever that's the case, and you're just doing a straight count like this, it's going to be a combination. So it's just as simple as this. You're choosing 5 from a group of 20. And by definition, that's 20 factorial over 5 factorial times 20 minus 5 is 15 factorial. Again, your calculator on the computer does not have a combination button, but it does have a factorial button. So if you want to reproduce this on the calculator, again, I'm going to use my phone calculator, which works really about the same as the computer one. You're going to put in 20 and hit the factorial button, then hit divided by, and then you want to do 5 factorial, so divided by 5 factorial equals, and then you want to divide again by 15 factorial, so you hit divided by 15 factorial and hit equal, and you'll end up with 15,504. So there are 15,504 different groups of 5 students that could be chosen from a group of 20 to go on this field trip. Simple enough. Another problem. How many 5-member committees can be formed from 8 men and 6 women if the committee must consist of 3 men and 2 women? Now when you come right down to it, this is really, from a high level point of view, it's just a multiplication principle problem, which says if you do a series of things, the number of ways to do the whole series of things is just the product of the individual selections. So basically here we're choosing men and then we're choosing women. So the multiplication principle would say the number of ways to choose the man, choose the man times the number of ways to choose the women. And order is not important, so it is a combination. So the number of ways to choose 3 men is a combination. You want to choose 3 men. Well, how many men do you have to choose from? You have 8. So you're choosing the men from the 8, and you want to choose 2 women, and there are 6 to choose from. So the product of those 2 combinations is the answer to the question. So let's see what that would be. That would be 8 factorial over 3 factorial times 8 minus 3 is 5 factorial multiplied by 6 factorial over 2 factorial times 6 minus 2 is 4 factorial. Okay? And again, you could take your calculator and do both of these. I've illustrated do both of these. I've illustrated 2 of these. I think I'm just going to skip doing this, but you need to take the calculator on the computer and make sure you can calculate each of these pieces. And if you can't, get some help. It turns out that 8 factorial over 3 factorial times 5 factorial is 56, and 6 factorial over 2 factorial divided by 4 factorial is 15. So it turns out there are 840 different ways that you could choose a 5-member committee that had 2 men and 2 women if there are 8 men to choose from and 6 women to choose from. And again, don't just assume because you watched me do a couple of these that you know how to do them. Make sure you can get 56 for this one and 15 for that one using the computer calculator.